Good morning, children. Next in Unit 4 of Atomic Physics, we are going to see a most important question. So last class I told you how we are going to determine critical potentials by Frankenheiser's experiment. And now I am going to tell you how we are going to determine critical potentials using Davies and Gouchers method. So in this unit, these two questions are very important for section C. So you have to prepare these two questions. Without these questions, the question paper will not be at all there. So you have to prepare Frankenheiser's experiment and Davies and Gouchers method. You should give more importance to this question. Okay. Now this question also you should write in 4 subheadings. One is principle, construction, working, explanation of the graph. Principle, construction, working and explanation of the. During working and construction, you must draw this diagram, and explanation graph, you have to draw this graph. Otherwise also there is some master. Principle, this works on the principle of excitation potential. That's all it is. 1 mark you will get. Principle, it works on the principle of excitation potential. Finish it. Here also written critical potential. Critical potential is nothing but it consists of 2 potential. One is excitation potential, ionization potential. Last class I told you about excitation and ionization potential. The energy expressed in electron volts required to raise an electron from ground state to excited state is called excitation potential. Ionization potential is the energy expressed in electron volts required to remove an electron from the inner space to the outer orbit. Finish. Now we are going to see the construction. So this is a glass tube. The glass tube is filled with the experimental gas which is going to be studied. Here the scientists Davies and Goucher have taken mercury. Using mercury gas, they have studied critical potentials. Using mercury gas, they have studied critical potential. So in this diagram, the glass tube is filled with the experimental gas under study. That is the first point. Experimental gas, bracket you can write mercury. F is a filament. That filament is heated by a low tension battery. That means when you heat the filament, electrons will be emitted. So C is the cathode, P is the plate, that is the anode, and G1 and G2 are the grids. They will be maintained at a very high negative potential. In the last experiment also I told you that the grid is maintained at a very high potential. Likewise here also the 2 grids are nothing but filters. They are maintained at very high potential. There in the diagram are marked VA, VR, V. VA means accelerating potential. VR means retarding potential. Retarding potential is the potential required to bring the electrons to the original state. V is the potential. G is the galvanometer. The electrons are falling on the plate, a current will flow. That current is measured with the help of a galvanometer. Then I mark K. K is the reversing key. That means again the electrons after collision will to ground state. Again you must make to fall them on the filament. Filament will get heated and the process will be going on repeatedly. For that we are using a reversing key. So G1 and G2 are grids. F is the filament. C is the cathode. B is the battery. G is the galvanometer for measuring current. P is the plate. K is the reversing key. VA is the accelerating potential and VR is the retarding potential. Okay. Now you may have a doubt. Sir, why you are putting arrow mark? That means variable potential. You have to increase the potential slowly. So it is variable. You can increase from in steps of 2, 4, 6, 8 or 10, 20, 30 or 100, 200, 300. So it is variable potential. If at all it is marked arrow means you have to remember it is a variable potential. So again I tell you the construction. Another one. There in the upper part of the glass tube is one arrow mark where written to pump and gas inlet. That means to bring the gas inside the glass tube, you have to pump the gas. So that provision is provided on the top of the glass plate. Sir, now you will have a doubt, sir, why sir you are doing for mercury? Okay, you can do for mercury or any other gas also. But the Davies and Gouchers have taken mercury as the gaseous material here. The experimental gas as mercury. You can change the different gas and do the same experiment, and you can find what is the critical potentials for that particular gas. So that is the inlet for gas, and after the experiment is completed, you can pump out the gas through that. So this is the construction. So first I told you principle, it works on the principle of excitation potential. Second I told you construction. Construction you have to draw the diagram, then you have to put all this, it is connected with the plate B, cathode, plate with all that is construction. Finished. Now what is that working? What is the working? The experimental gas is filled in the glass tube. Okay. Now the filament will be heated by a low tension battery. Electrons will be released, and these electrons will be within the region C and G1. I told you in collision two types of collisions: elastic collision, inelastic collision. Here, elastic collision will take place. The electrons will collide with one another. Due to collision, they will be picking up energy. That is called accelerating potential. Due to collision, the electrons gather energy or potential, and that potential is known as accelerating potential. Now you should remember, only those electrons which are having energy greater than the grid G1 will be able to travel to the region in between G1 and G2. So now the electrons will travel the space between G1 and G2. There it is known as VR, retarding potential. That means the electrons which are moving very fastly will be reduced in speed, and they will be able to cross G2. There is one important point. G2 and the plate P is made up of photosensitive material. The grid G2 and the plate P are made up of photosensitive material. What is meant by photosensitive material? Whenever an electron strikes, suddenly the galvanometer will show a indication. That means so sensitive. That is what photosensitive. If a small electron goes and strikes the plate also, the galvanometer will show a deflection, small deflection. So that is known as photo. So G2 and P are made up of, that is grid 2 and the plate P are made up of photosensitive material. So after the electrons crossing G2 are made to fall on the plate P. Now, when they are falling on the plate P, a current will be there. That is what recorded by the galvanometer, and it is a very small current, and that current is measured in terms of milliamperes. The voltage is measured in terms of volts, or you can go millivolts also. But in this experiment, the potential is expressed in volts and the current is measured in milliamperes. So the indicator current will be flowing, and due to that the galvanometer will show a indicator. Now we have got 4 terminals. That 4 terminals are known as reversing. Inside the dotted line I have shown 4 dots. That is a reversing key. Reversing means either you can make electrons to go from ground state to excited state. That is, you can make negative potential to flow, finish the experiment, again make the positive electrons again. So that is what reversing key. There you have got a small potential V. VA is accelerating potential, VR is retarding potential, and V. After that again the same process is repeated. After reversing, the electrons will be coming to the filament, they will get heated, they will come out, they will go in C and G1, collide due to collision. After gathering energy, they will get accelerated, flow in between the region G1 and G2, they will be having more energy retarded, then they will flow through G2, form the plate current. This process is getting repeated. That is what working. From this, we are going to draw a graph. That is the 4th heading. First I told you principle, second one is construction with this diagram, working, and third is explanation of the graph. Explanation of the graph. So I am drawing a graph taking x-axis and y dash axis and origin. So on the x-axis I have taken accelerating potential VA, unit is volts, and on the y dash I am taking galvanometer current, which is expressed in milliamperes. Now I am varying the current in the accelerating potential in terms of 2, 4, 6, 8, 10, 12. So I am taking so many volts. 2 volts, 4 volts, 6 volts, 8 volts, 10 volts, 12 volts. And here this current is in terms of milliamperes. This current is in terms of milliamperes. Sir, why sir there is one gap? At the starting, electrons are released. They will have low energy, so they will not collide. When no collision is taking place, no changes. So further they are moving, colliding with each other, and they are getting accelerated. Energy they are moving forward. So they get accelerated and they are moving forward. And at a particular volt of 4.7 only they are starting, and this curve reaches S. So I am drawing a curve SQR, and opposite is SQ dash R dash. I marked here 4.7 volt, 6.7 volt, 10.4 volt. In last Frankenhertz experiment, I marked 4.9 and 9.8. We were not able to differentiate between the excitation potential and critical ionization potential. I told you that was a drawback of Frankenhertz. But Davis and Gouchers, very good experiment where you can differentiate between the excitation and ionization potentials. Here the first one is the excitation potential, second one is the ionization potential, and third one is the excitation potential. After third excitation, you can see that no excitation takes from ground state, is going only to the excited level. Again, it is not coming to the grounder. That is what in the graph I marked. So first there is a rise in and there is a fall, and suddenly rise, and two arrows are moving in the same thing. That means first the energy is nothing but excitation, ionization, excitation. I told you what is meant by that. When an atom or electron or an ion is moving from the ground state to excited state, it is taking energy along with it, absorption takes place. When an atom is jumping from the excited state to ground state, it will give out energy, and it is known as emission. Subsequent absorption and emission will take place due to the variation. So now we are varying the potentials. Due to the varying of potentials, they get accelerated, again retarded. Retarded means once they are returning to the old state or original state. So means they are losing energy. Gaining energy, losing energy, gaining energy, losing energy. So if you draw in between these two things, we get a graph as shown in this one. So in such a reaction, electrons in the excited state return to the ground state with the emission of spectral radiation. This spectral radiation falls on G2, and that photoelectrons are released. When it is falling on G2, photoelectrons will be released from the plate. Now G2 will become negative with respect to P2, so that the photoelectron released from P cannot move towards G2. So you will be using the reversing key. So now it is 4.7. Now we are increasing. When VA is increased beyond 4.7 volt due to deeper penetration of the accelerated electron into the collision region core, the atoms will get excited. So excitation, ionization, excitation. That is what taking place in this one. So all these will be leading to the same thing. Here due to collision, the electrons get ionized. Due to the inelastic. When elastic collision is taking place, excitation takes place. When inelastic collision is taking place, they are getting ionized. So here elastic, inelastic, elastic. Collision, no collision, again collision. Here it is excitation potential, ionization potential, excite. So hence 4.7 and 6.7 are called excitation. These two are called excitation because here it is decreasing and rising to the excitation. And 10.4 is the ionization potential. 4.7 is the excitation potential. 6.7 is the excitation potential. And this 10.4 volt is your ionization potential. This method thus enables us to distinguish between excitation potential and ionization potential. I told you already what Frankenhurt's experiment had two defects. One, we were not able to maintain vacuum for a very long time. Second, we were not able to differentiate between the excitation and ionization potentials. So after Frankenhurst, Davies and Gouchers challenged. They told that we will take mercury gas, same procedure, but they are using two grids. There they use only one grid. Here they are using two grids, and they performed the experiment, and they were able to give a very good fitting result to Frankenhurst. That is what these experimental results are very much important than Frankenhurst, because with the help of this experiment only we are able to clearly identify the excitation potentials and ionization potentials. So these two experiments are very important for section C question. So whenever you are writing that questions, we have to write principle, construction, working, explanation of graph. We need diagrams. You draw the diagram with a pencil and scale, so the marks awarded will be very higher, so that you can score good marks. Thank you.